Effect of temperature on velocity of sound. So earlier we discussed velocity of sound in air medium. V is equals to square root of gamma p by rho, which is from Laplace equation. So from here gamma is the ratio between specific heats, Cp by Cv, which is gamma. P is the pressure, it's a pressure. Rho is density of air, So now I'm talking about PV is equals to nRT. PV is equals to nRT. PV is equals to N is what? Small m by capital M RT. So mass is what? It's a density into volume. PV is equals to density, volume, RT by capital letter M. It's a V and V cancels. So now we can say P is equals to rho, P is equals to rho RT by M. This is pressure. From this, P by rho is equals to RT by M. So now I'm talking. This is about velocity of sound in air under root of gamma P by rho, which means square root of gamma as it is. P by rho is what? Here, this is what? P by rho is equals to RT by M. So this is P by rho is RT by M. So which means here this V is directly proportional to absolute temperature. V is directly proportional to absolute temperature. From this, R is constant, and next one, M is, it's a constant. I'm considering as a constant, and gamma also constant. So from this, we can make the statement velocity of sound is directly proportional to square root of absolute temperature. It's a absolute temperature. The question is based on dependence of velocity of sound on temperature. Calculate the increase in velocity of sound for 1 degree Celsius rise. Here 1 degree Celsius rise temperature. So at 0 degree Celsius temperature, the speed is what? The velocity of sound is 332 meter per second. So he's asking about, now you can check on this one clearly. So here is the given question. So for the first one I'm talking on this. This is velocity at 0 degree Celsius. The velocity of sound is V naught, which is 332 meter per second. And so at T degree Celsius, let it be, at T degree Celsius, velocity is Vt. So what will be this Vt? So first I should find on this. First one, what is the condition on this? Vt or V is directly proportional to square root of T. Here you know this, it's a 0 degree Celsius means 0 plus 273 Kelvin. And T degree Celsius means what? T plus 273, okay? It's a Kelvin. So now V1 by V2 is equals to square root of T1 by T2. from this V1 is V naught by V2 is Vt. It's a V2 I'm taking as. Square root of T1 is 273 by T plus 273. So this is V2 by V naught is equals to under root of T plus 273 by 273. V2 is equals to V naught times, okay. So it's what? 1 plus T by 273 to the power of 1 by 2. Now, from this, I can write as, so the value T by 273 is a small value. For the smaller values, 1 plus x to the power of n is equals to 1 plus nx is the binomial expression. Okay, V2 is equals to V naught times, okay, V naught times 1 plus T by, so 273, this T means it become as 1 by 2. V2 is equals to V naught times 1 plus T by 546. This is the velocity of sound at T degrees Celsius. Okay. So finally, we get from this one V2 minus V naught. V2 minus V naught is equals to V naught into T by 546. Okay. So the increase in this T by 546, so you are getting as V2 minus V naught. This is equals to V naught is 332. For 1 degree Celsius means 1 by 546. I'm checking this. So this value is approximately 0.61. V2 minus V naught is equals to 0.61 meter per second. At every 1 degree Celsius rise in temperature, the speed of sound in air increases by 0.61 meter per second.